objective of this experiment is to study the variation of the resistance of the copper material with temperature. To find the Fermi energy of a copper wire, the formula one which is shown on the screen is used. Here, N is the free electron density, small a is the charge of an electron, capital A is the theoretical constant for the metals, R is the radius of the copper wire, L is the length of the copper wire, Me is the rest mass of the electron. Apparatus required: connecting wires, thermometer, milliammeter, millivoltmeter, copper coil, and stand. Circuit connections are as shown in the figure, or circuit diagram is as shown in the figure along with the nature of graph. Here we are plotting resistance versus temperature graph. Slope will be calculated and substituted to the formula. Circuit connections are made as shown in the figure. Here we are using a power supply one which supplies the constant current or constant electric current. An ammeter is connected in series. Positive terminal of the ammeter is connected to the positive. Negative terminal of the ammeter is connected to the negative. In order to calculate the potential difference across the coil, we have connected voltmeter across the coil. The positive terminal of the voltmeter is connected to the positive, and the negative terminal of the voltmeter is connected to the negative. Make sure the circuit is connected as shown in the figure. Hot water is poured into the beaker and wait till the temperature in the thermometer reaches maximum. Once the temperature reaches maximum, for every fall in 3 degrees Celsius, note down the corresponding potential difference across the copper coil. That means for every decrease in 3 degrees Celsius, note down the potential difference across the copper coil. Since we are using a power supply one which supplies the constant current, only potential difference across the coil is noted. And the tabulations are as shown. Using the tabulation, what we have tabulated using the experiment, we will be plotting the graph, that is resistance versus temperature graph. And here it is. It is a straight line, and the slope of the straight line is calculated and substituted in the formula. Here N is a constant, E, pi, A, R, L and M. These physical quantities are constants. Hence, the value for the constants have been substituted and simplified, and that is equal to 4.936 into 10 power minus 30. The square of the slope is calculated, and that is equal to 2.4025 into 10 power minus 6 multiplied or simplified. Then the Fermi energy of a given copper wire is calculated, and that is equal to 7.401 electron volt.